Okay, this is section 4.2b. We're just going to continue on working with substitution. Okay, we're back to the shapes. So they give you, this is just kind of a review, they give you these shapes. A circle plus 30, a square plus 2 is equal to 2 circles. So I'm going to take these out, and then for every square, I'm going to substitute in 2 circles. So that's 1, 2, 3, 4, 5 circles equals 30. If I divide each side by 5, my circle is 6. And my square is 2 circles, so that's 12. Okay, so I want you guys to do number 2. You can stop the video and see if you can figure out how to do that. We did a lot of these yesterday. You should have no problem doing this. So at this point, you can see that the shapes aren't going to work for us because no matter what, we have 2 variables left. We can't get this to a point where there are 2 variables. So I'm going to show you how to get away from the shapes, and we're going to go to numbers. So here are the steps to solving any system of linear equations using substitution. First, you're going to rewrite one of the equations so that one variable is expressed in terms of the other. So that means you have to have a variable by itself. Okay, so it means solve one of the equations for one of its variables. Then you're going to substitute that expression that you got from step 1 into the equation and solve for the other variable. Substitute the value from step 2 into the equation from step 1 and solve for the remaining variable, and then you can check. So let's move away from the shapes to numbers. So let's change these shapes into numbers. So we're going to make the squares x and the circles y. So here's my system. 2x plus 7 equals y. 3x plus 2x equals 35. All right, so we have y alone. What we're going to do, we know that this is what y equals. This is a y, sorry. We're going to plug it in where the y is instead of the y. So in this equation, I'm now going to solve 3x plus 2, and instead of the y, I'm going to put what we solved the y for in the other equation. I'm going to plug in 2x plus 7 equals 35. Now that we got rid of that y, we can solve for x. So I have 3x, now I'm going to distribute, plus 4x plus 14 equals 35. I'm going to combine, so I have 7x plus 14 equals 35. Going up here. Now I'm going to subtract that 14. So I have 7x equals 21. And when I divide by 7, my x value is 3. Once I get that x value, I'm going to plug that x value into my first equation. Instead of the x, now I'm going to put in the value I just found. So I have 6 plus 7 equals y. So y is 13. Now you need to go back and you need to write these as a point. If I graphed those 2 equations, they would intersect at the point 313. All right, so I'm going to make stars x, triangles y. So I have 3x plus 1 equals y, 2x plus 3 equals y. I'm going to take one of these and put them in. It says y equals 3x plus 1, so I'm going to take that and put that in instead of y in the second equation. 2x plus 3, and instead of y, I'm going to put 3x plus 1. Now I'm going to subtract 2x from both sides. Now I have 3 equals x plus 1. I'm going to subtract 1. So my x value is 2. Now I'm going to put that into the first equation. Let me erase this mess down here. So now I have, instead of 3 times x, I have 3 times 2 because we solved for x. Where was I? I was here. So now I have 3 times 2. We got that value from there. Plus 1 equals y. 6 plus 1 is y. So y is 7. And my solution is 2, 7. All right. So let's write a system of equations. So I'm going to make x the circle, y the triangle. Okay? So I have 3x plus 5 equals y. 3x plus 3 equals y. If you catch it, you know that we have the same slope here. And what did we say about having the same slope in different y-intercepts? We said that it's no solution. Let's look and see what happens when you try to solve it, though. If I plug this in for that, I have 3x plus 5 equals 3x plus 3. And when I go to move the variables to one side, I end up with 5 equals 3, and it's not equal. What would I see in the graph? You would see a set of parallel lines that never touch if you graphed this. Okay, you know where we're headed with this one. So let's write our system. Let's make the square equal x and the star equal y. So I have 2x plus y equals 21, and 4x plus 2y equals 42. When I get this into slope-intercept form, you'll have 2y equals negative 4x plus 42. And after you divide everything by 2, and this one too, when I move this over, I have y equals negative 2x plus 21. So if you catch this, you see that they're the same equation, so you will have infinitely many solutions. If you don't catch it before you solve, this is what happens. You will have negative 2x plus 21 equals negative 2x plus 21. You're going to add 2x to each side, and you're going to have 21 equals 21. What would you see on the graph? Same line. You'd be plotting the same line twice. Okay. So let's solve by substitution. No more shapes. We're done with the shapes. So I have y isolated. I'm going to take what y is equal to, and I'm going to put it in for the y in the other equation. So now I have 5x plus 4 equals negative 3x minus 12. I'm going to bring those variables to one side. So now I have 8x plus 4 equals negative 12. I'm going to subtract 4. So now I have 8x equals negative 16. Divide by 8. X is negative 2. Now I'm going to take that negative 2 and I'm going to plug it in here for x. So I have y equals 5 times negative 2 plus 4. So I have y equals negative 10 plus 4. Y is negative 6. Remember to put your answers together into an ordered pair. And this would be the place that the two lines intersected if you graphed them. All right. Let's solve by substitution first. I'm going to take that, what y is equal to, and put it in for y in that equation. So I have 6x plus 4 equals 6x minus 10. Well, wow, they have the same slopes, but let's see what happens here. I end up with 4 equals negative 10. So they're not, so that's no solution. And let's just quickly graph these to see what they would look like. That's the first one, and then here's the second one. Let me draw the line. We're going to have two sets of parallel lines that never touch. Okay, number 9. So we have the y is alone, so we're going to substitute that into the second equation. So I have x plus 3, and instead of the y, I'm going to multiply it by x plus 2, which goes in parentheses, equals negative 2. So I have x plus 3 times x, which is 3x, 3 times 2, which is 6, is equal to negative 2. I'm going to combine the x's, so I have 4x plus 6 equals negative 2. Subtract negative 2 from both sides. I have 4x equals negative 8. I'm going to divide each side by 4. So I have my first coordinate. Now I'm going to take this and plug it into the other equation. So I have y equals negative 2 plus 2. So y is 0. And that's okay. Remember, 0 is a number. So my solution in an ordered pair is negative 2, 0. Let's see if we can do one more before we have to go to a different section. This time I have x. Make sure you're substituting in the right place. I'm going to put this in for x. So I have I 2, I still can't write. So I have 2y minus 4 instead of the x plus y equals 2. When I combine my y's, I have 3y minus 4 equals 2. I'm going to add 4. So I have 3y equals 6. And when I divide by 3, I have y equals 2. Make sure that you plug it in for the y and not the x, because you found what y is equal to. So I have x equals 2, and instead of the y, I'm going to put in 2 minus 4. So I have x equals 4 minus 4. So x is 0 this time. So my answer is 0, 2. All right, let's look at the next one. We're not going to graph this. Move on. So number 11, we have y minus x equals 5. Well, the problem here is we don't have a variable isolated. So I'm going to get y alone for the second one. So I'm going to take 2x plus y equals negative 10 and subtract 2x from both sides. So that way I have what y equals. Y is equal to negative 2x minus 10. Now I can take what y is equal to and I can plug it into this equation. So I have negative 2x minus 10 minus x equals 5. When I combine these, I have negative 3x minus 10 equals 5. I'm going to add 10 to each side. So I have negative 3x equals 15. I'm going to divide by negative 3. X is 5. Now I'm going to take that 5 and I'm going to plug it into here for x. So 2 times 5 plus y equals negative 10.